This conference will now be recorded.
So today's topic is going to be trigonometry. Trigonometry is a very large topic and it has a lot of aspects and a lot of meaning in it, but we're going to start trigonometry from a geometrical definition of it. What is in geometry trigonometry? And since we're continuing with right angle triangles, we're going to start trigonometry in geometrical sense, and I will explain you geometrical meaning of it, and I will show you trigonometric ratios and what do they mean. So we know what's a right triangle, and we know that right triangle has three sides. Any triangle has three sides, and we have the two legs, one hypotenuse, and so on. Suppose we're given this triangle, and we have one. Well, of course, we have three angles, but one angle that is given here, which is called theta. And of course, for this angle, we know that it has two legs near it. So one is opposite to it. So we're going to call this leg opposite leg, and this leg adjacent leg. So adjacent leg is the leg that is near it. Okay, so of course, near this angle, we have two sides, hypotenuse and adjacent leg. So the leg that is near it, we're going to call it adjacent. The leg that is opposite to it, we're going to call it opposite leg. And the hypotenuse is 1 in any triangle. That's why we're not going to give any other name for that. So trigonometric ratios. We have three trigonometric ratios: sine, cosine, and tangent. So sine is written as sin, and for any angle we have a sine. So for example, sine of this angle is going to be the opposite leg divided by hypotenuse. So this trigonometric ratio shows the ratio or proportion of opposite leg to hypotenuse. So sine of any angle shows the ratio of opposite leg to that angle divided by hypotenuse. Cosine shows the ratio of adjacent leg over hypotenuse, and tangent shows only the ratios of legs, so the opposite leg divided by adjacent. So for now, I understand that it's quite not clear for you. That's why I'm going to show it on one specific example. So I will draw a right triangle, and I will denote this. So I will denote this as, let's say, alpha. We can call it any name. And let's say this is going to be 3, this is 4, this is 5. So I will write sine of alpha, I'll write cosine of alpha, and I'll write tangent of alpha. So let's go back and see what is sine. So sine is opposite leg divided by hypotenuse. Okay, so that means that for this triangle, so for this angle alpha, the opposite, so if I'm writing sine, I know that it's opposite leg over hypotenuse. So what is opposite for alpha, right? It's 3. So the opposite leg for alpha is 3. The adjacent one is 4. So in order to write the sine alpha, I would write 3 over hypotenuse, which is 5 in this case, because this is the right angle. So 3 over 5. Now, if we go back and see at cosine, it's adjacent leg over hypotenuse. So in this case, alpha and adjacent to it will be 3. So it will be 3 over, sorry, it's going to be not 3. It's going to be 4, because adjacent is the one that is near it. So it is 4 over 5. And tangent, we know that tangent shows the ratio of opposite leg over adjacent leg. So in this case, our opposite leg will be 3 and adjacent leg will be 4. So it's going to be 3 over 4. Of course, if I want to find, we have third angle, which is, let's call beta. And I want to find sine of beta. The definitions of cosine, tangent, and sine will not change. Sine is still opposite leg over hypotenuse, but since we're changing the angle, now for the angle, the opposite adjacent leg would change. So sine beta is opposite leg over hypotenuse. So if for alpha opposite leg was 3, for beta opposite leg will be 4. So it will be 4 over 5. Now adjacent to it will be not 4 in this case, it's going to be 3. So it's going to be 3/5. Then, and tangent will be opposite over adjacent. So 4/3. So I hope it's quite clear now. So we're going to continue with. So we mostly commonly use as a rule sohka toa. Why? Because S means sine, O means opposite, and H means hypotenuse. So for cosine, it'll be adjacent hypotenuse. For tangent, opposite over adjacent. So if you want, you can memorize it this way so that it's easier for you. So sohka toa. So suppose we have this kind of question. I don't want to do exact so I don't want to do like the solution of it, but I want you to just understand that. So suppose we're given an angle. So I hope you've seen in calculators that you have sine, cosine, and tangent there. So for any triangle, for any angle, you can find sine, cosine, and tangent. So for any degree, you can have a sine. So if, for example, you're given the angle and you want to find the side and you know one of at the other side, you can do this. So we have triangle. So in this triangle, we have this x, this 7, and this is 35. So we understand that this is ratio of two legs. That means we're going to use tangent. So tangent 35, in this case, it's not alpha, it's not beta, it's exact degree. It's x over 7. So x will be tangent 35 degrees times 7. And I understand that tangent 35 is a certain number which can be calculated in calculator. I'm gonna go into deep after the school break, and I'm gonna talk about these topics more. But what I want you to understand is that what is these ratios, what do they mean, and why do we need them? So let's do, for example, another example which already has the explanation here. So I understand that, okay, this is the degree. Again, I'm given one leg opposite to this one, and I want to find the hypotenuse. So I understand that it's opposite leg and hypotenuse. So I understand that I need to use sine. So sine of 49 degrees will be the opposite leg over divided by hypotenuse. So in order to find y, I would just have to 8 divided by sine 49. And if I calculate it on calculator, it will give me 10.6. So that's it for today. What I want you to understand and to remember what these trigonometric ratios mean and what each ratio represents. So which ratio it represents, like opposite leg over hypotenuse, adjacent leg over hypotenuse, opposite leg over adjacent leg. So for now, I just want you to understand this, and further, of course, we're going to continue with this topic and do more complicated stuff. Good luck.